Topic 2, Systems Development Lifecycle. You're very welcome. My name is Maureen Neal. Please keep in mind what you have shared together and learned in Topic 1, as it's very relevant as we move forward onto Topic 2. Up to now, we've focused on what information systems are, for example, an online banking system, and what is contained in their makeup, the components of hardware, software, databases, networks, people, and processes. We are now going to look at the cycle of activity that happens when an organisation wants to create a brand new system. This need could be driven from the need to improve and automate existing manual processes. Say, for example, an insurance company wants to process applications for life insurance online as opposed to paper-based transactions in their offices. Or it could be the creation of a brand new process in business. Say, for example, a new online digital bank wants to enter the Irish marketplace and wants to design their new systems from scratch. There are 4 steps in the systems development lifecycle: planning, analysis, design, and implementation. This can be considered to be a traditional systems development lifecycle model, as it's the one most used globally in systems development. However, new models are emerging and growing in popularity. Agile is one such model you might hear about. This course will focus on this well-established model described above. A separate course will be necessary to understand more about Agile. For now, it's useful for you to know about other models and that they do exist. This life cycle model can also be referred to as the waterfall method, because of the sequential steps, i.e. one follows the other, as it flows downwards from the planning stage right down to implementation. These phases cascade from one to the other in a waterfall effect, where progress flows steadily downwards through each stage. The next phase is only started when the goals for the previous phase are achieved and signed off. In essence, the waterfall model is a sequence of steps in which the output of each stage becomes the input for the next. Sometimes this model is described with 7 and 8 steps. However, the 4 key and core steps above are always present. For the purpose of this course, we will focus on the 4 steps above. Don't worry, you're not missing out, as where extra steps have emerged, they are really just breaking down the 4 overall key steps into more detail. If you think of the steps and apply it to something else to help understand it a little bit more, it can in fact be a bit like what building a house is like. There is a planning phase. The owner makes a list of the requirements and the architect sketches an outline plan, 1 bathroom, big open plan kitchen, etc. Then there's the analysis phase, when the owner sees the plan and he passes alterations to and forward back to the architect. This process continues until a more detailed plan is ready to go forward for planning approval. And finally, the design phase is completed. At this stage, the owner should be satisfied that the plans are a good representation of his or her desired house. In other words, the plan should satisfy most of his requirements. Some compromises may have been made during this stage. All well, planning approval is obtained. If not, you have to loop back and go to the previous step to start it again. Once approved, the build begins and we move to what could be considered as the implementation phase. Like building a house, if you don't get the right people involved with the right skills and don't get them bought into the process early, then things will go wrong and will get delayed. In developing information systems, people are key, and we touched on them in Topic 1 a little bit. Not only are they a key component along with the 4 elements of IT touched on in Topic 1, but they are the ones that know the processes that we also touched on in Topic 1. Some key people who need to be involved are as follows, and there's 5 of them. The first one is the boss or the business owner. Someone has to pay for the new system and somebody has to sponsor the piece of work. It's key that they are bought in and are kept updated throughout the development process. They won't be involved day to day, but they do need to be kept updated. They will expect the system to deliver benefits that are measurable. For example, faster processing speed on a loan applications if it's a bank. So maybe prior to the system being in, it took 2 hours. They want it down to 30 minutes. They might also want to see cost improvements. For example, if it currently cost a bank to process a loan application and when they added up all the costs, it was €15 per application, they might want to see that cost reducing to, say, something like 10. So they are their key areas of interest as the business owner, the boss. The next group of people are the users, who are sometimes called the end users of the system. In a bank environment, this could be the cashier in the branch who will use the new system being developed, or it could be the customers of the bank. So it's important that you get their input into what needs to be included in the design of any new banking app that they're expected to use. It's a mistake not to involve this group of people, as ultimately you could end up with a system that users won't use, as it doesn't meet their needs, but may in fact meet the needs of somebody else who designed it. Users are also really key to the testing phase, and we'll cover that a little bit later on. The next group of people are the information systems personnel. The information systems department contains a number of personnel that contribute to the creation of a new information system. The following people would normally be found under the information systems function. So first of all, you have what are called systems analysts. The system analyst is concerned with investigating the current system if it exists and extracting the requirements and functionality needed for the new system. Then we have the system designers. They will take the findings, conclusions and direction from the systems analyst and create a design for the new system. This design must equate to the requirements of the business users and business managers. Finally, you have the programmers. They will take the design of the new system and actually write the computer programs that will allow the new system to function. These programs will be in the form of screens, as well as maybe processes to, say, process checks at the end of the day. They could be a multitude of things. So they can be screens and they can be also background processes that happen. Next, we have management. This includes the management of the information systems department and the management of the business functions. The business managers will be concerned with the efficiency and effectiveness of the new system, and they will be coordinating the business requirements side of the project, ensuring that the organisation gets value for money and that the new system will be adding some tangible or intangible benefits to the organisation. Information systems manager ensure that the system has been developed within time and budgetary constraints. They will also ensure that changes to the initial design are controlled and that the impact of any changes is factored in. Whilst managing the various information systems personnel, they will also be ensuring that the business managers are satisfied with the progress of the system. And actually, both the business manager and the IT and IS manager will work closely together. It's actually really important that they have and build a good working relationship. It's likely the business and the information systems managers will only be engaged in the project part-time, as they will normally have their day-to-day jobs to do. They will work together to ensure one overall project manager is appointed to run the systems development project. The project manager is ultimately responsible for the delivery of the system and reports to the system owner on a regular basis. The project manager can be either a business person or an information systems person. She or he must have full authority for the project and is therefore usually a senior person within the organisation. Depending on the size of the project manager may also have some support staff in roles like business analysts. We won't go into project management in any more depth on this course, but if you choose to learn more about project manager styles and people, then you'll learn an awful lot more about these different types of project roles on that course. So finally, the last role is key, and it's the operations team. This team are responsible for the running of the system, both at the development and testing phase, and once it's released into the go live, for want of a better phrase, working environment. They will ensure that the system is available to the appropriate people during the appropriate times. This group also controls any programs that need to be run against the system, either in online or batch mode. Other areas of work carried out by them include software and hardware upgrades, the purchasing of new equipment, and the support of the IS department and business areas. The following people would normally be found within the operations function. So you'll have network administrators. And these are specialists who design, install, troubleshoot, and optimize computer networks to work. You've then got security administrators, and their job is to manage security and privacy controls within the system and on the organization's network. You then have the database designers, and they will create a file storage mechanism, usually in the form of a database, which will hold the information required by the system. The developed programs will be able to access this database and query, amend, insert, and delete the data that exists there. Finally, you have the system architects. They build and manage the architecture and platform that the new system is built on. Their area of concern includes the operating system, external interfaces, performance, standards, and integrating different technologies. So take note that depending on the size of the project and the organisations, these roles could be scaled up or scaled down. For example, a systems development project for a small recruitment company developing a new client recording system would be very different in scale and size from, say, a bank developing a new online banking application. So in this topic, we've looked at the systems development lifecycle and the people and roles that need to be involved. Before we move on to topic 3, let's take a quick look at the strengths and weaknesses of this system development lifecycle model. The strengths and weaknesses of the traditional model are outlined in the slide above. So strengths. It's an easy to understand and use model. It can provide a lot of structure, particularly to inexperienced staff who've never used it before. It has very detailed, structured steps. It's also very good for management and control and reporting, and it works well for large-scale projects. Some of the weaknesses of the model are that all of the requirements of the system must be defined at the start. So in that respect, it's not flexible because you can't decide 3 months in you want to add in a big development requirement. It's not very dynamic in that respect, so you do need to know everything up front. Integration is another big task at the end, so obviously everything is delivered in a lump sum at the end of the project, so you have to make sure that when you integrate it into the live environment, you do so in a very carefully and considered way. And in that respect as well, the value that the business get, so whether it's the reduction in costs or the increased in time processing that we talked about earlier, it's all only delivered at the very end of the project. You don't see bits and pieces of change as you move along. So as a model, it is a great fit, and it suits scenarios where the requirements are well known up front. Also, where the technology is understood, it's not brand new technology that people are exploring with. It's maybe used in an organisation before and this is a further iteration of it, or it's a stable technology. Perhaps where similar types of projects have been run and successfully using the same software. So that's the end of the slides on topic 2. However, please complete the remaining activities on Moodle to help to reinforce what you have learned here today and before you move on to topic 3. Thank you.